Welcome to qnawire.
From the known value of atmospheric pressure at the surface of the Earth, estimate the total number of air molecules in the Earth's atmosphere. Right. So our estimation, we're going to start from the ideal gas law, but for a for the for number of molecules as opposed to number of moles. So we have PV equals NK T, where K is the Boltzmann constant, T is temperature, capital N normally, so number of molecules, Boltzmann constant, temperature, pressure, volume. And we're going to make number of molecules a subject of this equation. So this becomes N is equal to KT, is equal to PV over KT. And we're going to establish what these amounts are. So we kind of want to get an estimate of the volume of the atmosphere. And one standard estimate that I have been told that if you take the Earth's the volume of the atmosphere as constant, you're assuming sea level volume. It's basically a 10-kilometer shell on the Earth's volume, and the radius of the Earth is given by our Earth is given by 6.371 or 6.37 to 3 significant figures times 10 to the 6 meters. And that gives us the atmos. So assuming a 10 kilometer, so 1 times 10 to the 10 to the 1 times 10 to the 5 meters gives us 1 times 10 to the 4 even, 1 times 10 to the 4 even. So V atmos is given by 4/3 pi r cubed. So 6.38 times 10 to the 6 cubed minus 6.387, even 6.37 times 10 to the 6 cubed. And that gives us an estimate of the volume of the atmosphere, which turns out to be equal to 5.11 times 10 to the 18 meters cubed. So then we've got one thing now. So we got the we have the volume that we need in this equation. So in the equation there are 4 variables that we need to put in there. We have the volume now. So the next two, the pressure and the temperature, are we're going to use standard temperature and pressure conditions because that's what we have to assume based on what the question says. So P is equal to 1.01 times, that looks like a 6, my apologies, 1.01 times 10 to the 5 pascals. And our Boltzmann gas constant K is equal to 1.38 times 10 to the minus 23, and that is and then our temperature is given by 273 Kelvin. And we substitute all of those numbers in, and substituting all of those numbers into this equation here, we get that N is equal to 1.37 times 10 to the 44. The answer in the textbook is 1.1 times 10 to the 44. This is an estimate, and with estimates, if you're within order 10, so you really want to be something times 10 to the 44. If you're within order 10, that's a reasonable enough estimate because it's not exact. So